Hey, welcome back. We are looking at 4.2 today, which is reflecting graphs of functions. So here's the warm-up question. Before we go on to the new stuff, why don't you give it a try and see how that goes. Okay, I'm assuming you're finished. The point 3, comma, negative 1 is on the graph. So what happens after the translation here? So this x plus 2 here, this recall means that we have horizontal translation by negative 2, moving 2 units to the left. This is a vertical translation up by 4. Okay, moving up by 4. That means 3 comma negative 1 will turn into, well, translation 2 units left, so minus 2. So 3 minus 2 is 1. Move up by 4, so negative 1 plus 4 is a 3, and there's your answer. Okay, so that's what we did last lesson. We are going to be looking at reflection today. Okay, so here it says a graph may be reflected in the x-axis or in the y-axis. The image graph is congruent to the original graph, but its orientation may change. So congruent means it's the same size, same shape really as well, but it just reflected. So the orientation may change. Right? Orientation is different, but it's the same size, same shape. Okay. It says given the function y equal f of x with the point a and b on the graph. Okay, I should say x and y because I changed that. I forgot to change it here. Y equals f of negative x. So what happened here was we replaced x with negative x. So this is a reflection in the y-axis. Okay, so again, this may seem odd. We're just changing x to negative x. Why is it a reflection in the y-axis? If you think about it, if we switch x to negative x, that's like if x value was a 5, it becomes a negative 5. Well, it's reflecting over the y-axis, right? It's the vertical line that it's reflecting over. Okay, so it's, again, this may be a little bit confusing, but if you just kind of have the grid in your mind, well, I'll try it out, I guess. If it goes from positive 5 to negative 5, it's reflecting this way. So this is reflection over the y-axis. You can think y-axis is the mirror. Okay, so it's actually a reflection in the y-axis. In other words, y equals negative f of x. So here we're changing y value to negative, or from negative to positive. This is a reflection in the x-axis. Okay, and the coordinates of x and y, if there was a reflection in the y-axis, again, that means we're switching x values from positive to negative, or from negative to positive. So x becomes negative x, y remains the same. If it's a reflection in the x-axis, that means x remains the same, but y becomes negative of what it was before. Okay, so here's the first example. Let's take a look. It says here's the graph of y equals f of x. Sketch the image graph after a reflection in the x-axis. State the domain and range of each function. So for the original function, let me just write down the coordinates first. Hopefully this graph looks familiar to you. Right? This is the one we used in the previous lesson. You'll see this graph again later on. We're going to use this one for, I don't know, 3 times, 4 times, something like that. Okay, so here are 4 points. This is going to turn into a prime, like I showed you last time. A prime, b prime, c prime, d prime. Okay, we are reflecting over the x-axis. So here is the x-axis. If you're reflecting over this way or that way, that means we're changing the y values. That means x values remains the same. So negative 3, negative 1, 4, and 5. However, the y values are just going to be negative of what it was. This was negative 1, now it's going to be positive 1. That was a 2, it's not going to be negative 2. 0 remains 0, right? Negative 0 becomes negative 0. Negative 0 is still 0. Negative 2 becomes positive 2. So now here are our 4 new points. We can plot. Negative 3 and 1 is here. Negative 1, negative 2. 4, 0 remains the same. 5 and 2 now. So there is my new graph. This is my image graph. Just missed it. There you go. Okay, so there is the new graph. Now we can figure out the domain and range. For the original function first, recall this was from negative 3 to positive 5. Again, from left to right. Range means from bottom to top. So the bottom, the lowest point is -2. The biggest y value is a 2. Okay, so now we can see from the graph that the domain remains the same. Okay, and actually the range also remains the same. Now this doesn't always happen. In fact, it does not happen most of the time, right? It's luck, pure luck. Okay, but they actually both remain the same in this case. Okay, so that's the first example. Here's the second question. That's the practice. Good luck. All right, so here are the 4 points. -2, -2. B is -1, 2. C is 3, 2. D is 1, 0. The domain in this case goes from -2 to 3. And range goes from -2 to +2. Okay. Okay, so now we're gonna have our A prime. This is a reflection in the y-axis, so we are flipping this way, right? So the x values is going to be the opposite. The sign for the x value is going to be opposite. C prime -3, D prime is -1, whereas the y values remains the same. Okay, the y value all remain the same. Okay, there we go. We can plot 2 and -2. 2 and -2 is here. 1, 2 is here. -3 and 2 is here. -1, 0 is here. There is the graph. Now you can see this case domain is going to be different now. Okay, so this goes from -3. So that's my leftmost point. To the rightmost point is at 2 for the x value. Range actually remains the same because we're reflecting over the y-axis. So all the we're reflecting over, yes, that's right, y-axis. Therefore, y values do not change. Okay, that's it. That's it. Okay, so again, the previous example, in the example 1, this was a reflection in the y-axis. So f of x actually becomes reflection in the x-axis, which means we are changing the y value. So this actually becomes y equals negative f of x. Whereas this one, this is reflection in the x-axis, so y equals f of x becomes y equals f of negative x, because we're switching x to negative x, right? You can see -2 becomes +2 and so on. Okay, here's the second example. I guess I kind of just show you how to do it already, because this time it doesn't tell you which one it reflects over, but it shows you in the equation here. It says we are going to graph y equals f of negative x, and this one tells you to graph y equals negative f of x. So this one means changing x values from positive to negative and vice versa. This one is changing the y values. So actually I'll let you try both of these and then see how that goes. Pause the video. All right, we can take a look at this one here. We are reflecting over x to negative x, so over y-axis. So we're changing all the x values. So all the x's are going to be the opposite side now, okay? So this is going to be now 2.879. This is +2. This is 0.653. 0 remains 0. Positive 0.532 becomes negative 0.532. The y values will all remain the same. So 0, 3, 0, -1, 0. Now we can plot. 2.879 is 1, 2, 3, somewhere here. 2, 3, 2 and 1, 2, 3 is here. 0.653 and 0 is somewhere here. 0, -1, that does not change. Negative 0.532 and 0 is somewhere here. So the graph becomes like this. Like that. Okay, now for the domain. Domain, remember, it's the possible x values. You can see it does not change. Remains the same. Range, this time, it does not change either because it's still all real numbers. Okay. Right? Because it keeps going up and keeps going down. Okay, there we go. That's the example 2. Hopefully you got that. For this practice question, we are now making the y values negative, so all the x values will remain the same. Now let me change it to green. Okay, all the x values remains the same, negative 2, negative 1, positive 1, 1.397. The y values are going to be the negative of what it was, so negative 1.667 now, negative 2.083, positive 0.583, 0 remains 0. Okay, so now we can plot. Negative 2 and negative 1.677 is somewhere here. Negative 1, negative 2.05, something like this. Right here. 1 and 0.5, so 0.583 somewhere here. I guess I can do this one here. This is a nice point, 0, 1, so that becomes 0, negative 1. 1.397 and 0, so that'll be somewhere. Oh, actually, that's exactly the same spot. Okay, so now it looks like this. Okay, there we go. So that's what it looks like. Domain remains the same, still all real numbers. Range is now going to be different. We had a minimum, so that's why we had y is greater than equal to negative 0.583. Now we have a maximum, and the maximum is right here. And what is that? That is 0.583, is it? Yes. So now y has to be now less than or equal to positive 0.583, because that is now our maximum. Okay. All right. Hopefully that's okay for you. We'll be looking at our last example here. Today's lesson is not too bad because we're just looking at reflections. Okay, example 3. What is the equation of the image of y equals x squared after reflection in the y-axis? So there's a reflection in the y-axis. This means we are replace x with negative x. So this y equals x squared actually becomes y equals, again, replacing x. Again, I need to emphasize this again. We are replacing every single x that we see, okay? Replacing x with negative x. So you can see x becomes negative x. Interestingly, this actually becomes the same, right? I mean, if you expand this, if you simplify this, it's still y equal to x squared, which makes sense. Recall, this is a parabola u, and we know that this graph is symmetrical. So even if you reflect it in the y-axis, actually it just, I mean, the same thing, right? This portion becomes that portion, and the left portion becomes the right-hand side portion. So it doesn't really change. Okay, so here's the practice question for you to try. Good luck. Okay, so it says, what is the equation of the image after reflection in the x-axis? Okay, so now in the x-axis means we are, recall this was y equals negative of f of x. So what we are doing is we are putting a negative sign in front of the entire function, okay, in front of the entire function. So y equals 1 over negative 3x squared minus 2x minus 1. This actually becomes y equals negative of this, okay, negative of what it was. Now obviously we can apply the negative sign to either the numerator or denominator. I'm going to put it into the denominator because then I can make everything positive. So this will be the answer. Okay, so I just want to show you, I know this is not part of the question, but I just want to show you what happens if in the second practice question here, if there's a reflection in the y-axis. Again, if it's in the y-axis, that means we're replacing x with negative x. Okay, so if reflection in y-axis, then we would have y equals 1 over, again, we're replacing every single x with negative x. So there's my first x, so I put a negative x there. There's my second x, so I put a negative x there, and then minus 1. If you simplify this, negative x squared is now positive x squared, right? So actually doesn't change. Whereas the second one, the negative or minus 2 times negative 2x, minus 2 times negative x actually turn into plus 2x, and then minus 1. So that would be the answer if there was a reflection in the y-axis. Okay, so that's it. That's it for today. Okay, so the quick summary, I suppose, would be if there's a reflection in the y-axis, you're replacing x with negative x. If there was a reflection in the x-axis, then we're doing this, which means we just put a negative sign in front of the entire function. And if it's a reflection in the y-axis, that means we're changing x to negative x, or the x values to negative x values. So if it was positive, it becomes negative, negative becomes positive. If the reflection in the x-axis, we're changing the y values. Okay, let's think about this. It says when the graph of a function is reflected in an axis, which points are invariant? Okay, so for example, if reflected in x-axis, then which points are invariant? Then are invariant. So you think about it while I write this down, okay? And reflected in y-axis, then what will be invariant? Okay, so if you think about this, if it is a reflection in the x-axis, okay, so x-axis is this one here. Well, the points on the x-axis will not change because that's where you're reflecting on, right? So it's not going to reflect. So the x-intercepts are invariant, okay? Whereas if you have a reflection in the y-axis, then the y-intercepts, usually there's only one. So I should say the y-intercept is invariant, okay? If it's a function, you can only have one y-intercept. Obviously, it does not have to be a function. Or it says it's a function, so there you go. There's only one y-intercept, okay? You could have more than one x-intercept though, right? Okay, number 2, suppose the graph of y equals f of x is reflected in the x-axis, and then its image is reflected in the y-axis. What is the equation of the final image? Okay, so first question, we have a reflection in the x-axis. That means y values are going to change. So that means we're going to put a negative sign in front of the f of x. And then it says, and then this image is then reflected in the y-axis. So if it's reflected in the y-axis, that means x becomes negative x. So then y equals negative f of negative x. So that would be the answer for the first question. Okay, you simply put a negative sign in front of both the function and the x. Number 2, would the equation be different if the graph were to reflect in the y-axis first and then in the x-axis? Of course, it's not going to be different because, I'll show you. Well, if we have a reflection in the y-axis first, then it is y equals f of negative x. And then we have a reflection in the x-axis. That means we put a negative sign in the front of the entire function. And you can see they are the same thing. Okay, so when we are doing reflection, the order does not matter. Okay, you can reflect in the y-axis first or x-axis first. It's the same thing. Same thing with translation. It does not matter if you translate horizontally first or vertically first. Okay, it does not matter. Okay. You know what? I'll end it right here. Okay, so we'll leave it till the next lesson. Okay, so that is for this lesson. Again, if you have any questions, let me know. Okay, otherwise try your practice questions. Good luck.